हेलो एवरीवन, वेलकम टू अनदर वीडियो ऑफ स्पार्क। आज की वीडियो हम लोग स्पार्क एग्जीक्यूशन के बारे में समझेंगे और स्पार्क इंटरनली कैसे काम करती है विथ रिगार्ड्स टू टाइप्स ऑफ ट्रांसफॉर्मेशन, विथ रिगार्ड्स टू हाउ पार्टीशनिंग कैसे मैनेज करती है। इसके डिटेल्स में रहेंगे तो देयर विल बी मिक्स काइंड ऑफ टॉपिक्स विल बी डिस्कस्ड इन दिस वीडियो। अगर आप मेरे चैनल में नए हैं तो प्लीज़ चैनल को सब्सक्राइब करें और वीडियो पसंद आए तो वीडियो को लाइक और शेयर ज़रूर करें। जैसे मैंने पुराने वीडियोस में बताया था कि आरडीडी इज ए डिस्ट्रीब्यूटेड डाटा स्ट्रक्चर। जैसे हम लोग आरडीडी बनाते हैं तो द डाटा गेट्स डिस्ट्रीब्यूटेड। अब ये डिस्ट्रीब्यूशन का मतलब क्या हुआ और ये डिस्ट्रीब्यूशन से होता क्या है? सो व्हेन वी क्रिएट एन आरडीडी और व्हेन वी रीड ए फाइल इन ए स्पार्क, in at that time the RDD or a data frame is created. So I will assume that data frame is created, and when the data frame is created, the data is divided into small parts, and that each parts becomes a partition. So RDD जब divide करती है डाटा को, that is a logical division, and that partition that is created is a logical partition, which means that partition is not at the disk level. तो डिस्क लेवल पे कैसे पार्टीशन होता है? जैसे ये डाटा आप स्क्रीन पे देख रहे हैं, दिस इज द होल डाटा लेफ्ट साइड, राइट साइड इज द टू सेट ऑफ डाटा. Now, in the Spark or in the big data scenario, you will be using any of the cloud storage, or you will be using HDFS, where data will be partitioned on the disk basis. Like in HDFS, when you store the data, it will be created into different replication layer also, and the data will be partitioned. So this is the physical partition. So in the physical partition, we assume that there are two partition. So when we read this data and create a data frame or an RDD, and we specify that there will be three partition or two partition, or by default there will be some partition which the Spark will create depending on the memory, depending on the data size, and depending on the CPU which you have. So for example, it creates the three partition. So this three partition is created on the top of this two partition, two physical partition. On this partition, we are creating a three logical partition, and this three logical partition is actually the partition what we call in the Spark. So when we read a data frame, or when we read a file and create a data frame, and already it creates a distributed data set, and that distributed data set gives the partition concept, and that is the partition, and your task and executor will work on that partition. Now this partition helps you to work parallelly, because your program, your task will work parallelly on this partition. So I hope this partition thing is clear. It's a logical thing. When that particular data frame is destroyed, when that particular RDD is destroyed, that partition, that logical partition is also destroyed. Now we'll discuss about the Spark jobs. What is Spark jobs? What are Spark stages? But before that, I want to discuss about what is action and transformation in the Spark. So transformation is something which helps you to apply the business logic. सो यू नो दैट आरडीडी इज इम्यूटेबल. सो आप आरडीडी को ट्रांसफॉर्म नहीं कर सकते हैं. यू नीड टू क्रिएट ईच टाइम ए न्यू आरडीडी. So what it actually means is that you have to transform it to create a new RDD, or you have to transform an existing data frame to create a new data frame. So when you apply any logic, that is called transformation. For example, in this code you can see, if I'll just remove this one, so you see that I'm applying the filter condition here. I'm applying the select. I'm just doing the group by. These are the transformation. So there will be a set of transformation in the Spark code. So now what is action? So in the Spark, the action is something which gives you the result, which makes the end of the loop. I'll tell you what is that loop I'm talking about. So this count is an action, select is an action, your collect is an action, dot show is an action. These are the actions. So on each action, Spark creates a job. Okay. So how it is created, I'll show you now. So for example, when we read a file, so I'll just comment all this line, and then I'll show you how it works. So what I'm going to do, I'm just going to read a CSV file without giving an instruction that it should be header should be true or info schema is true. I'm just going to read a CSV file, and I'm just trying to, what I'm going to do, I'm just trying to show this df. Okay, I just want to read it. I'm not doing anything. So as I told, read is also an action. So when we'll read a file, it should create a job, it should create a Spark job. And this line I have entered so that this your Spark session will be live till the time I press any key. so that I can go to the Spark UI and I can show you that how the Spark job is created. So what I will do, I'll run this, just save this. I'll run this job. So this particular program is, it's getting executed, and enter to continue. So I'll go to the Spark UI. So this is my Spark UI. You can see that jobs, in the job section, you have one job, and each job should have one task. So it is one task to read the file. So I have read a file and it creates one job. That means there was one action, and with the and to one action, one job has been created. Now again, I will go to this one. If I read a file and give this option, like reading a file is one action, and applying this into that CSV is one of the transformation, and it acts as one of an action. So what I'm going to do, I'm just going to comment this df. अब इस df में हम लोग फाइल को रीड कर रहे हैं. There is one action, applying the filter like header should be true, inference schema should be true. That will be another action. So I'm going to run this one. Okay. Okay. Save it. Okay, Spark session will be live. I'll go to Spark UI. I'll refresh this page. So you this see this, there will be two jobs. So there are two action being performed. One reading the CSV, applying the options in the CSV, that is another job, and both are under the CSV method. So these are coming under the CSV. You can go to the stages. You can see the stages. You can go to directly SQL and data frame plan. You can click on this. You can see that how this is being done. Okay, so if you have a complex job, you can go to this DAG and you can see how this execution plan has been created. Okay, now I'll go to another thing. So your other things like so, count, these are the actions. Okay, so transformation is something which we are doing the transformation, like we are doing the filter, we are applying the where clause, we are doing the group by, these are the transformation. Now transformations are basically two types. One is narrow transformation and another one is wide transformation. So narrow transformation is that kind of transformation where the each partition work can happen parallelly. I mean, like when you do select star from an employee table, so the select query will be fired into different partition of the employee table, and that can work parallelly. So that is a narrow transformation. I'll show you with an data example. Okay, so we have this same data. Okay, now we are assuming that Spark, while reading, after reading the CSV, three partitions are created: part 1, part 2, and part 3. So when I fire the command, just select command. Okay, so this select command can work parallelly in all this partition. So that means select is a narrow transformation. Okay, now if I do the group by command, if I write it here, group by on I can say department. Okay, so what will happen, this will work on this partition, and then again there will be a shuffle and so on, because I have to bring each department data into a single partition. So this IT department will come into one partition. So this will, all the IT department will come into this partition. Okay, so what will happen if we do the group by, after this will happen in the process of shuffling. Okay, so all this will, sorry, so all IT department will come into one partition, HR will come into another. I'll write it here. I'll write it here. Your HR will come into another partition. Okay, one more is HR here. And this finance will come into another partition. So that means when we do any of the white transformation, in that case, your data gets shuffled. And for example, in the in the group scenario, all the similar kind of key, because I'm doing the group on the department, so my key becomes the department. Okay, so on the value of the department, that partition is created, and that happens with the internal mapping with any kind of mapper algorithm, and shuffle sorts happen, and this is created. And if I'm going to do count on this group by, I'm going to count it, then separate count will work on this three partition. Okay, if you have more department, it will create more partition, and it can be more partition than the unique value of the department, depending on how we are repartitioning the data. We'll not go into the detail of that, but the whole purpose is, in the wide transformation, the shuffle and sort happens. So shuffling is the movement of data from one partition to another. That partition can be in a single node, or that partition can be across multiple nodes. So after the shuffling, the same key data becomes the partition, and then the count. If you apply the after group, if you apply the count, you apply some summation, any kind of aggregation thing, that will work on this shuffled partition. Okay, so there is a narrow transformation, there is a wide transformation, and depending on this logic, the different stages are created. We'll see how it is created. I'll go to Spark. Now we are in the Spark. We'll go to, okay, now we'll just change the program. We'll just create where clause. Okay, we're not going to do repartition. We'll do the group by. We'll do the count. Okay, count dot show. Okay, and then this one. So what we are doing, we are reading the CSV file, giving the header equal to true. Header equal to true. It means it will take the schema name from the header. So if you see the file here, employee.csv, I would have opened it somewhere. Yes. So this is the schema, name, address, department, age. Okay. And then what we are applying the where clause with department ID is name, IT, and select name. So what I will do is just remove this one. I'll just do the group by. So what I'm going to do, I'm doing the group by and department ID, and I'm doing the count and this line for making the Spark session live. Okay. So I'm going to run this program. Let me save it. Okay. So there is some indentation error. Control S. Okay. So now when we go into the Spark UI, we'll refresh this page, and you will see that these many jobs are being created. So two jobs, 0 and 1, that CSV one is like what we have discussed. One for reading the CSV, another is for applying that header and info schema. The other is, it will be of the group by, and then the other will be of the next will be of the count. So there are how many jobs? 1, 2, 3, 4. You can go to the final job, and you can see how the stages are there, or you can directly go into the stages, and you can see that how many tasks are inside the stages and how these stages are being worked. So I'll go to the final one, and you can see what is happening there. The shuffling of the rows are being happening, and then again it is creating a map partition already on the top of it. So if you go on the job, you can go into any of the, like the second job. So what is happening, you can see there. So in the SQL, you can go like this is for reading the CSV, and this is for the other purpose. When you click on this, you can see like hash aggregation is done. This is actually creating the partition. Like we have a department ID, so how the Spark will understand that each department ID is unique, how to put the same kind of department, same sorry, value of the department ID into the same partition, so that summation or counting can happen parallelly. So that is done with the hash algorithm, and this is being done here. This shuffling is happening here, you can see in the exchange one. So how many records are being shuffled, how many records are being merged, what are the duration, you can see there. In a complex program or any of the logically big business related program, this will be very difficult to understand, but at least you can understand what is going to have, what is happening, how many jobs are being created, each action performs a job. Okay, and depending on the narrow and wide transformation, number of stages are being created. So you can look into what are the executors say. Now in my case, this is a local one, so we have a driver and that is doing the full work. But in a cluster formation, you can see the multiple executors. So in the database environment, I can create a multiple I'll create a multiple what do you call nodes, and that will act as an executor, and there you can see the number of executor. In our case, it's a driver itself, because we are running in a local environment. We are again running it in a local mode, and you can see that what all things are being run. CSV, then something's happening here, so statement is here. So everything you can see in this timeline. So once your Spark session is like, if I kill this Spark session by enter to continue. So now if you go to the Spark UI and refresh it, this page will be not available. So I think you would have understood most of the thing, like what is Spark job, what is Spark stages. There are tasks inside the Spark stages. Okay, what is narrow transformation, what is wide transformation. Multiple interviews are around these topics. Okay, so when the Spark jobs are created, how the action is performed, and how you can see the Spark UI and analyze your code. So the purpose of the video was to give you this understanding. These all topics club into a single format. So in this part, the complex scenario happens. So what all things which I have explained you is in a very simplified form. If you want to go more detail into it, then you can go into the Spark documentation. But they have not written everything about the Spark framework, how it actually works, because it's very difficult and it's very complicated to understand each part, like how that shuffling happens, how this exact DAG is created. So internal are very complex. I hope I am able to clear all this topic in a very simple way. And if you have any further doubt, and if you want to know more details about anything of this topic, please post your comment or you can write a mail to me. तब तक के लिए अपना ख्याल रखिए. Take care and happy learning.